Figure 5.7 is kind of a helpful graph to really understand a couple of concepts. Number one, just purely the fact that clay can hold more water than sand can. So one of the activities you're going to be determining this week is the gravimetric water content. Okay, theta G. This is the volumetric here. So another reading of water content in soil. And so you can see by volume, this particular clay can hold 60% water by volume. A couple of things that tells us is that clay can hold a lot of water, number one. And number two, that clay has a lot of pore space, a lot of space to hold water. So it can hold water, it does hold a lot of water because it has lots of pore space. And clays are, even though they're a fine material, they have lots of finer pore spaces, as we've seen in previous chapters. So that's number one. Number two, we have water potential, soil water potential graphed here going more negative. Okay, so which one holds water the longest, for instance? And again, we can see that sand doesn't hold water very well for very long. Okay, because this curve here acts like that. With something like a loam or a clay, you can see that if we're at a more negative pressure, let's just say right here, okay, for three different types of soil, a clay, a loam, and a sand, you see that loam can hold quite a bit, clay can hold even more, even when it's under pressure, okay, even when it's under, the soil water potential is very negative, okay. As we move along here, we see that the loam comes closer to what the sand is holding, while the clay is still going to hold quite a bit of water. As we move towards these very highly negative pressures, you'll get much less because we're trying to pull all the water in that instance out of the soil. So a couple of lessons from this that make sense with what we've seen before, and then the things that we're seeing this week in terms of the more negative pressure, typically the drier the soil, but also we can just apply, and in this case what we did is we just took a clay soil, put it in a ring of some kind that we could apply a suction to, and we just started pulling that water out of that soil at different pressures. So we got more and more suction on it towards the very end, towards this side of it. And we found that we could of course pull most of the water out of the soil, but it looks different in terms of what sorts of texture you're dealing with it. Clay holds a lot of water, and clay can hold water for very long, even when there's a lot of suction applied to it, and that would look in a field like when it's getting drier and drier and drier, clay can still hold a good amount of water.